Good evening and welcome to Science Cafe Concord. My name is Dan Marchek and I'd like to welcome you all here. How many of you have been to a Science Cafe before? Okay, so what goes on here is this is a forum for a conversation. It's a chance for us to talk about whatever the topic is with some experts and learn so that we're all better citizens and we can all make better decisions, hopefully in the end. So tonight, the format is very simple. We'll give the panelists a chance to introduce themselves, tell us about who they are and why we should listen to them. And then we'll throw it open to you for questions. So David and I will both have mics and we'll be walking around. So please use the microphones because we are recording it. We have to thank the Draft for having us here, the Concord Monitor for supporting us, and Concord TV for filming it tonight. So we'll be available on cable access, which is something really great that they're doing. So tonight our topic is 3D printing. And with no further ado, I'll turn it over to our moderator, David Brooks.
Thank you. I'm Dave Brooks with the Concord Monitor. And Dan pretty much took everything I was going to say. So those of you who've been here before will have heard this, but it's worth repeating. This is a difficult venue for the wait staff because of the way the tables are, because we all come and leave at the same time. So kids generously, they deserve it, plus they give us the room free, so we want them to be happy. The other thing is so Dan did mention, he moderates the Science Cafe in Nashua that happens the first Wednesday of the month. He and Sarah Eck, who was out in Hopkinton, they started Science Cafe almost 6 years ago now. About 6 years ago, they approached me, actually, say, hey, we want to start this thing, you want to be part of it? And I said, sure, that'd be a great idea, and it lasts, I figured it'd last 6 months and be fun, and then it would end. And we have done, 50, 60 of them now. We started up here in Concord, actually moved down to Nashua, and then expanded back into Concord this year when I came to the Monitor. So we have 2 of them going right now. And because there's also a Science Cafe that is run in Manchester by the Sea Science Museum, I'm confident that New Hampshire has the highest per capita Science Cafe rate in the country. So even though the ones that were run by the universities, Dartmouth used to have one, UNH used to have one, and they putzed out. But those of us who were doing it for free.
Dartmouth does have one.
They still have they? Ah, excellent. Even better. So anyway, topic is, let me see, I think that's it. Topic, as we said, is 3D printing. And as Dan said, I'm going to very quickly introduce our 3 panelists and then ask them to tell us in about 2 minutes or less why we should pay any attention to them. And then I will ask the first question, and after that, it's up to you. So if you don't ask questions, we'll sit here and stare at our food. All right, so our panelists are, let's see, in this order. We have, first of all, we have Jeff Hapgood, who's with Technology Education Concepts here in Concord. And then we have Matt Minuti, who is with the Manchester Makerspace, which is fairly new. Makerspace, you can talk about that if people want to know as well. And anybody here from NHTI? Because they had actually approached me about, hey, we should start a makerspace. And I said, that's a great idea. Anyway, all right. Okay, and finally I have Bill Dahl, who is Vice President of Customer Experience for SolidScape in Merrimack, which is a company that makes 3D printers and is quite knowledgeable. So he can particularly talk about the commercial and business side. So very quickly, tell us, why we should pay any attention to what you say.
Good evening, everyone. My name is Jeff Hapgood. As he said, I work for Technology Education Concepts. So we're a small company that supplies 3D printers, among other things, to schools around the country and locally. We've been doing 3D printer business for schools since 2001. So we've sold a lot of machines. We've gone through a lot of technologies, a lot of changes in the business, a lot of changes in the products. And I will give you any information that you want. Education is our focus. We're mainly an educational company, and have some ideas on that and can supply you some information on that, and be glad to answer any of your questions.
I'm Matt Minuti from the Manchester Makerspace, and so for those of you who don't know, a makerspace is kind of like a almost like a gym with tools. Basically, you want to make stuff, and not everyone has access to a full wood shop or a metal shop, welding equipment, 3D printers, etc. And so I'm the education director, and I help out with just about everything that Makerspace does, and we use 3D printers extensively, and we'd love to get people using them. I've personally been using 3D printing stuff since about '09, which I imagine probably puts me to be the relative newcomer here, but soon you will be.
All righty. So don't judge by the gray hair. I've been at SolidScape for 5 years. So I come from other disruptive technologies. My name is Bill Dahl. And before 3D printing, I was in 3D glasses-free video, which is kind of a very different technology in and of itself. At any rate, I guess the question was, why should you pay attention to us? And in my case, it's less about me and more about the who we talk to. I spend most of my time talking to customers, finding out what their needs are, going pretty much around the world in all sorts of different applications. That gets translated to the new product development, how we service the customers, our conversations with them. We keep a keen eye on the competition, and we're in a lot of shows where we see a lot of the technology as it emerges. So fortunate enough to have some customer insights that may be valuable to you, and happy to answer any questions. Thank you.
Excellent. You guys are, usually at least one of the panelists just goes on and on and on when I do this, so I'm very impressed. All right, so I will, actually before I start, let me ask, how many of you, raise your hand if you have ever used a 3D printer? And raise your hand if you've ever seen it, even if you weren't doing it yourself in the library. So pretty much all of you, but is there anybody who knows nothing at all about 3D printers? Excellent. All right, good. We one of the great things about Science Cafe actually is this kind of spread of knowledge in the audience. Much better than having a lecture when everybody's an expert or a lecture when nobody knows anything at all. So anyway, so as a result, my first question is going to be to you, to the local guy here, to tell us, particularly for the folks who know nothing about it, explain very quickly how 3D printing works, what it is, how it works. Go.
Well, there, as everyone up here knows, and probably a lot of you know, there's a lot of technologies. So 3D printing has come to the public's eye based on some fairly simple technologies, fused deposition modeling, which is extruding plastic, almost like a hot glue gun in an XYZ coordinates, and building pieces up layer by layer from nothing, versus, and also usually known as additive manufacturing, versus subtractive manufacturing. So in the old days, you took a block of wood, a block of titanium, you milled out, you removed material, you subtracted material. With 3D printing, you're adding material layer by layer, usually in almost every technology, somehow, some way, with different materials. So you have an advantage there in creating geometries with 3D printing that cannot be created subtractively, at least not easily, even with the most complex CNC machines. There are parts, I have some parts here if people want to look at them later in different technologies, but that couldn't be really created very well, even with a 5-axis CNC machining center. So 3D printing is basically additive manufacturing, building from nothing and extruding, either extruding, melting. There's a lot of different technologies used, but that's the basic of it.
Excellent. All right. Now, any questions out here? And if you have a question, raise your hand and we will bring the microphone to you. Please wait for the microphone so that the camera, the TV can pick it up.
Over here.
You mentioned plastic for additive building of parts or whatever, what other materials have been on the forefront or maybe even being used right now instead of just plastics?
Metals are probably the hottest thing right now. I mean, that is, to me, kind of the holy grail of where manufacturing and industry wants to see 3D printing go, is to print metal, the same way that they're machining metal. Aerospace, they want metal parts most of the time. I mean, they do deal with plastic parts too, biomedical. But there are metals, there are lots of different plastics. So when I say plastic, there are a multitude. The consumer 3D printers would have 50 different materials, different plastics that you can use. And then you've got the metal powders, you've got nylon powders, lots of things. I mean, Bill could probably talk to the SolidScape products and what they use for.
Sure. Well, we actually put a 3D spin on a centuries-old technology or technique called lost wax casting, which is basically still the most precise way of getting casted parts, which speaks to all, many of the industries you're talking about. And what we end up doing is we print wax. We print two different kinds of wax, and wax is really kind of a gateway to any material that you want. So in one of our large markets, which is jewelry, we're one and done. We print custom rings, or our customers print custom rings, high-end rings typically, and they cast them. There's only one of a kind, and they are done. Jewelry line, they may do what's called a silver master. They'll print and cast one, then create a silver master that's then used in a variety of different molding methods to create a mold that can produce many, many more of the same kind with the same precision. But we're also used in this technology, again, the wax being a gateway to any material, it's being used in biomedical research. We're involved in bone and tissue scaffolding research. We've been involved with Arizona State University in terms of doing cerebral aneurysm, and there are many of the companies, including some companies that Jeff represents as well, that are in these spaces. And what's coming soon, how this will affect all of you in the not too distant future, is right now there are a lot of patient-centric or specific modeling being done for non-critical or even some critical applications, like Phoenix Children's Hospital will literally print individual heart models of very young children for pre-surgical planning. That's one of the early applications that's almost at the doorstep of the operating theater, but still takes too much time. There are many other medical procedures where basically surgical care or it's already happening in dental implants, facial reconstruction, replacement knees, all sorts of different things are now at the point where they're getting to be patient-specific and coming to an operating theater near you very, very soon.
Another thing that's very kind of useful, almost in the opposite direction, is instead of going into the high-tech medical side of things, more into the hobbyist/entrepreneurial aspect, which is very much sort of more in my line of things, is that if you design something for 3D printing, you can test it out in plastic of some type, and test fit it, say, yeah, this works, this doesn't work, and you say, great, I've got my design, I like it, and now have it made in maybe steel, maybe silver. I know of a number of people who have prototyped jewelry pieces in plastic and then worn the ring around for a little while and say, no, I don't like that after all. And try it again, and after they get the one, yeah, I do like that, in plastic, of course, because it's super cheap, then using actually your machines to produce the real one. So there's a lot of kind of bridging the gaps.
Let me actually ask a question? So we're talking quickly about, you get your design and you make it print out. So can one of you or all of you talk briefly about how you actually make a design and get the machine to actually print the thing you want
Okay.
it to?
All right. Well, I got to get on my soapbox there a little bit, but that's really the separation from mainstreaming 3D printing to, in the last couple of years, everybody probably heard about 3D printing. It was on the news, it was everywhere, right? Everyone's going to have a 3D printer. But where we are not yet is at the place where I put in a part and I press the button and out comes exactly what I want. Or are we at the part where everybody is capable of producing a design that can be 3D printed? Because we're still looking at the experts in the business are people that know CAD software.
CAD meaning?
Computer-aided design, to produce models that are actually fully closed and that can be printed. I don't want to get too technical there, but you have to have a certain kind of solid model that's completely closed, can't have holes in it, and there's not an easy CAD software. I mean, there are getting to be some, SketchUp, and there's Space Claim and Key Creator that are doing kind of a less than a parametric CAD, if I'm going too deep there, but it's still difficult. So everybody can print something if they want to download files on the internet. There are thousands, maybe a million, I don't know.
Probably tens of millions.
Tens of millions of files online that you can download. So if you owned a 3D printer, you could print something, but it wouldn't be your design. So what's still limiting us to some degree is the design. The only other thing that gains us a little bit there is the other way to get a print, other than downloading it or designing it yourself, is scanning. So 3D scanning is another thing that is really getting big, where scanners are getting very inexpensive. I mean, we have one that's $400 that I could walk around and scan people here and produce a 3D print. In 2 hours you'd have a bust of yourself in a printer with a $400 scanner and the software that comes with it. Well, yeah.
So, yeah, absolutely. In fact, I have a number of 3D scans of myself that I plan on doing pretty much exactly that with for fun, because why not? As well as one of me holding my cat up like that. So I had access to a 104 camera 3D scanning contraption that I helped build at a previous job. But 3D CAD software is actually something that a lot of people are working on to try and reduce the barriers to entry. A lot of people like things like SketchUp, for instance, as he mentioned, because a lot of schools will use it. It's very quick and easy to learn. However, it's also very trivial to accidentally make designs that have holes, as was said, meaning that it can't actually exist. This cup has a hole in it, but a hole for water, not a hole that goes into nothingness. But I was actually involved with a project as a lead developer on some 3D CAD software aiming towards a fifth grade-ish age group that's being used now in a bunch of schools all over the world called BlocksCAD. That's sort of like describing the shape almost mathematically, like cylinders subtracted from cubes and spheres and adding them together and things to describe the shape. And so we're kind of dropping the barrier to entry slowly, steadily, and that's kind of the trend, getting more and more accessible.
Well, and things are getting a lot more simplified. So one of the good things, and I was seated at a table with Lynn over there, table 8, is it? He has an engineering background, and he's seen a lot of changes in the technology. But what's exciting, and we were talking a little bit about it, is a paradigm of what happened to probably some of the people in this room, and certainly some of the parents of children in this room, where Apple took off and had a big push into education. And it's great to have someone who is dealing specifically with introducing this into the classrooms. The fact that inexpensive and still very productive machines can be exposed to children, or children exposed to to this technology is great, because much like they embraced Apple and took those technologies and went on to great innovations, the kids of today who are getting grounded in some of the simpler applications and design software are going to be some of the future innovators. And so there's another big wave that's going to come as a result of this. We're just at the beginning.
All right, another question? One here.
I'm interested in what scale we're talking about now with respect to reproduction, and what scale are we talking about in the future with respect to manufacturing? I'm wondering how high can we go on this? I mean, how much can we grow on this with respect to, and be reasonable about it?
You mean grow in terms of size?
Size, yes. Yeah, growing, because this is such a precision type instrument. Are we limited to small jewelry or other things? I know biomedical as well, but how big do you think this can go with respect to reproduction?
Small building scale. There's been a number of people who have built basically 3D printers, same exact idea, using concrete as the material instead of plastic, and laying it down gradually and building up layer by layer, small, like shed-sized buildings. I think there was an article going around on the internet of someone who used that to build like a little castle in their backyard. I mean, obviously that takes a certain amount of mechanical and technical know-how in order to construct a machine that can do that, but realistically, the scale issues, it can go as large or as small as you can imagine. I've seen one that used plastic that was about 2 stories tall, printing out the same exact way, basically trash can sized pieces. And it was only because they wanted to be able to produce many pieces instead of just one huge thing.
Yeah, and I don't know if you were also asking about the scale of how big will it be in manufacturing, because there's still, with plastic especially, it's still less expensive. If you need 1 million parts, you're not going to 3D print 1 million parts. You're going to make a mold, you're going to injection mold. It's still much cheaper to injection mold. The advantage of 3D printing is if you need 100 parts. If you're servicing old equipment that you don't want, the tooling is gone, you don't want to pay $50,000 to produce a tool to injection mold, you only need 100 parts, 500 parts. That's where it fits. It also fits in customization. The other part that's getting big is the metal printing. I mean, General Electric is investing untold amounts of money into metal printing. I mean, they're trying to buy, there's only about 5 metal printing companies, 6 metal printing companies maybe in the world. They tried to buy 2 last week. They just bought they got refused on one. They just went to another one. They just bought that one. So, I mean, they are investing this whole facilities that are doing nothing but additive. And the thing there is the complexity. So they can take, in one case for their jet engine part, 14 different parts that you used to manufacture, that you used to inspect, that somebody had to draw and produce drawings on, that somebody had to go out and purchase and source, and then quality control when they came in. They can print it, 1 part. Think of the savings. I mean, this is where they're getting the money to do what they're doing. But so the scale of that is big. The scale of metal printing for custom things. They can also design differently. As they've said, you don't need to design. Before you were designing, you knew you had to machine something on a mill or a lathe. So you had to make your design a certain way to be manufacturable. With 3D printing, you can get, and this is what we're trying to get the kids to think about, is that you can think completely differently now. You can say, how do I make this part the best way? I don't have to worry about whether I can get a tool in underneath there and fit a tool over here to do this and that. I can build it from nothing, so I can change the whole way that I think about design. And probably these guys are more design people than I am, but I think that's one of the big things that's going to change.
yes and no. My background's electrical engineering, yet I seem to do mechanical things all the time now. But I've seen firsthand kids doing things like, let's design a little car, but let's design the car so that it's printed with wheels that move, that are already in place, no assembly required. And at first that sounds like, what is going on? And if you're from a more conventional background and you're not familiar with the capabilities of 3D printing, that sounds absurd, it sounds difficult, it sounds like a Turner's cube issue if you're familiar with machining. For people who don't have those preconceived restrictions, then they can just kind of adopt that, I guess, and kind of jump straight into it and say, yeah, that makes sense. It's just, there's a little gap there, and here's a wheel, and here's the body, and here's what keeps the wheel from falling out. Great. So there's a lot of mental changes, I guess, as well as the physical capabilities.
So we've come to the end of our time. Please thank our panelists. Our moderator, David Brooks. And we do take December off, so there won't be Science Cafe in December, but on January 17th, the topic will be...
I don't know yet.
Okay. A surprise. So thank you all for coming.